Hey everyone, in this video, let's take a look at question 3, longest substring without repeating characters on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given a string s and we want to find the length of the longest substring without repeating characters. Let's take a look at what that means through these examples here. Go ahead and paste them. Okay, so in this first example, essentially what do we have? Well, we have all of these characters, right? And the answer is ABC. Why? Because first of all, it's a substring, and secondly, it's a substring without repeating characters. You can see that this is also a substring, but notice how here the A is repeated, so we can't have that. So basically what we want to do is we want to go through the array, or we want to go to the string. We can maybe generate all sorts of substrings, and then we can calculate if they have any duplicates, and if they do, we don't consider them, and in the end, we consider the longest one. Now, if you just think about this, generating all substrings, well, first of all, that's an O of n time operation. Then for all of them, you have to check whether there's duplicates, so that's another O of n. So this would actually be an O of n cubed type operation. So it's very slow, and this is not the correct way of doing this question. So then how might we go about doing it? If we don't want to generate all sorts of substrings, then how might we go about doing it? Let's take a look here to see how they kind of arrived at this answer of ABC, right? Okay, so let's take a look. And I will put this, let me just maybe start off here. Okay, what can we do here? Well, if you notice, first of all, we have access to this string here. And what we can maybe do is we can just start off at the left-hand side, and we can gradually increase our so-called substring, which I'll refer to as window. I'll refer to this as window. We can gradually increase our window until we have some sort of duplicate. And then we could decrease our window. So what might this look like? And this is just one of those questions where we introduce a new type of programming method. This is called a sliding window type method. And I'm going to explain here why exactly it might come into handy to use some sort of sliding window. Okay, so let's take a look here. And by window, maybe I'll just denote it with these two brackets here. So this is our window so far. Okay, so let's say we're over here. Let's say my left pointer is over here. In these sliding window type problems, you always have a left pointer and you always have a right pointer. That's just how these problems are done. Okay, so in the start, left and right are equal to the same value, and we see that we don't have anything in our window. So what do? We add this to our window. So now A is in the window. Now we check. We move the right pointer ahead, and we check. Okay, can we add this B? Well, yeah, it looks like we can add the B because it doesn't seem like there's any repeating characters. Let's go ahead and we add the B here. We add the B. So now we have A and B, and now we can move a right pointer ahead again. Right pointer always moves ahead. Right pointer is kind of like we can maybe do this in terms of a for loop as well, where we just like loop over this right pointer all the way to the end. But I like to have like 2 pointers just to kind of really make it clear that we're forming a window here. But anyways, what do we do now? Well, now we extend the window. So now the window gets extended till here, ABC. And now what do we notice here? Well, first of all, we notice that we have a window, right? So one thing we should maybe be doing is keeping track of the size of the window, because we want to return the length of the longest substring. So maybe I can do something like size is here. What is it? Well, it's just 3, right? It's r minus l plus 1. That's just the kind of formula you have to know. It's just r minus l plus 1. That will give us the size of the window. Okay, so we have that. Now what about now? Well, we move r ahead again, and then what? Well, now here is my window. My window is something like this. Now, is this allowed? Well, this is not allowed anymore, right? Because first of all, we are including a duplicate, and that breaks our window. How do we know we are including a duplicate? Well, we can see here, we have access to the A here, and so I can maybe keep track of like all of the elements I've visited so far and their count, right? And then once I come across an element here, I can basically check, okay, does the count exceed 1? If it exceeds 1, then I know that my window has been broken. What does this mean? If my window has been broken, then if I were to extend my window, like even if my window goes all the way here, and these are all like unique elements, the window is still broken because of this one value here, this A over here. So in these window type problems, these sliding window type problems, what happens is that if you are at a good solution, then you can increase your window. If you arrive at a bad solution, then increasing your window further will still keep you at a bad solution, etc. So that's how that will work. So now let's take a look at what we can do here. Well, now we notice that we need to keep track of the elements, right? We need to keep track of their counters. So initially, A is just 1, and then B is 1, C is 1, and now A, it becomes 2. Well, now what can we do? Well, now we have to shrink our window, right? Because we know that this is invalid, which means this will be invalid, etc. So how do we shrink our window? Well, we have our L pointer here. We can shrink it that way. So what can we do? Well, this L pointer here, why don't we move this one inside one? So now our L will be at the B. And notice now, then since we moved outside of the window, this A, suddenly it was 2, but now it's going to be 1. And we notice that this is a valid window now. This is a valid window. And even if we were to shrink this even further, that would still be a valid window. Okay? So now what do we notice? Well, now we notice that the size is still 3, so we're still not ahead of like our maximum. So what can we do now? Well, now this is our window. And as I mentioned before, R will always go forward. So we increase R over here. And then we can see we have something like this. When something like this, again, we're breaking our window, right? Because the B is repeated twice, so B will be repeated twice here. And what it means is that if we were to extend our window even more, then we would still be basically breaking it. So what do we need to do? Again, we need to shrink our window. And this is how these types of sliding window problems are done. You can think of it as a window, and we try to extend it as much as we can. And then if we break it, then we kind of slide the left pointer inwards, and we form smaller and smaller windows. And then we go from there. So in this sense, we're kind of like forming all of our substrings. If you think about it, if you really kind of draw it out, and you see all of the windows are forming, we're kind of forming all of the valid list of substrings here. Okay? So in this case, B is equal to 2. So move L inwards, and our window will now start over here. So remove this, and our window will start over here, and then B becomes 1. And now similarly here, what can we do? Well, we obviously have to move R forward. So now we'll arrive at something like this. But notice here that again, the C is duplicated. The C becomes 2. So again, this does not work. So we do not update our size. So we have to increase our L. So now we have something like this, where this should actually be like this. Okay, so now we're again at ABC, which we were at before. Now I increase this, and notice now if I go to increase my window, again, we run into the same scenario where B is repeated twice. So this should actually be 1. B is repeated twice. So if B is repeated twice, what do we do? Well, then we actually have to decrease our window. So we decrease our window, and when we decrease our window, notice this. Our A becomes 0, but notice our B is still 2, right? Our B is still 2. So we have to decrease it again. So we keep decreasing the window until we arrive at a valid solution. We decrease it again, and then we arrive at this solution here. Okay, and now the size is 2, and so it's still not greater than 3, but again, we can keep going. So if we arrive here finally, we increase our window to the maximum over here, but we can still see that this is invalid, right? Because B will again be 2. Then we decrease our window here. We decrease our window here, but again, we notice that B is 2, C becomes 0, and we still increase it 1 more. So now L will be over here, and the window is just this last thing over here. And then basically this is valid, and then R exits out of the string. So this is how we tackle our like window problems or sliding window problems. And you can do the same thing for this example here. So let's take a look at how we write the code for this. It's actually pretty simple, and the structure we follow is almost always the same. So let's take a look. Okay, so first thing we need to do is we notice that S can be empty, right? So let's just handle that case. So if not S, then we'll just return 0 because that's the length of the longest substring without repeating characters. Otherwise, what? Well, we need a way to keep count of the letters, right? So in this case, a set would actually work because we're just looking for like duplicate, like one duplicate. But in general, we might have like something like longest substring without K repeating characters, right? So in general, I just like to use a dictionary for this. And this will be like my hash map. It'll be a default dictionary. And so what we need to do now is we need to define our left and right pointers, which will initially both start off as 0. And again, this can be actually done in your for loop, and then you could just maybe advance your left one, but I like to do it like this. So now what? Well, now I need to define my for loop, or not my for loop, my while loop, while R is less than length of S, right? Well, we're going to do something, and at the very end, we will increase our R, and then at the very end, when we're done this while loop, we want to return our result. So our result will hold the length of the longest substring without repeating characters. So initialize it here as 0. Okay. So what do we need to do first? Well, the first thing we need to do is if we're at this element here, if R is at this element here, and actually left is also at this element here, first of all, we need to add this to our dictionary, right? Because we just viewed a letter. So I can do something like D S at R plus equals 1. So now what have I done? I basically said that A has a count of 1. Okay. So A has a count of 1. Now what do I need to do? Well, now I need to check that this doesn't break anything, right? Maybe it's not so obvious here, but let's say I'm over here. Then at this point, A will be 2, B will be 1, C will be 1. So basically, we've broken our condition here. So what can I do? Well, I can do something like this. So I can do while S at R is greater than 1. Then what do I need to do? Well, then I need to decrease my window. So how do I decrease my window? Well, first of all, I need to remove whatever letter is over here, right? Which may or may not be A. It doesn't have to be A, but it may be A, it may not be A. So I will do D, S at L, the left string, I will decrease by 1. So here, this one will now become 1, which in this case, it actually happens to be the same letter, but it doesn't have to be. We saw that in these cases here. And then I will increase my L. Okay? And that's all. So now, L will be here, and we notice that this is actually valid. And we can actually do this until L is less than R, right? So we don't want to make L cross R. It wouldn't actually cross R, but this is just something like good to add. It wouldn't actually cross it, because if it crosses it, then like it just wouldn't. Like if you go ahead and draw it out, it just wouldn't cross it. So that's our while condition here. Now what do we have? Now we have a valid window, so we can determine the size, and we can do res is equal to maximum of this, or R minus L plus 1. So here, the length of the window is, if you think about it, so 0, 1, 2, 3, R is 3, and L is 1. So it's 3 minus 1 plus 1, which gives us a value of 3. So that's basically all we have. And so we will go through this, and we will create all of the sliding windows. And so then, what am I doing here? So this should be D at S at R. Okay, so let's go ahead and run our test cases. And we'll go ahead and submit. And we can see that this works. So what about the time and space here? Well, the time is just O of n, right? We're just going through the string. The space is kind of also O of n, because we're storing this in terms of a dictionary. But again, we could have used a set here. Okay, I hope this question helped.